Hello, so I'm continuing the Advent of Code challenge on the Acorn Electron. So today is the first day of the actual challenge for 2020, so doing it for real now. So this is the first time I've seen the challenge, and I'm going to try and do it live. I'm lying, I read it a bit before starting the challenge, so I've got an idea of what I want to do already. Okay, so the challenge, there's a really convoluted story, but the gist of the challenge is that you have a big list of numbers and you want to find the two numbers in that list that add up to 2020. Okay, so there's quite a long list of numbers. So I guess the really obvious algorithm would be to just iterate over each number, to have all the numbers in an array, and then iterate over each element of the array, and then within that loop iterate again to check if any of the numbers add up to 2020. So I guess, yeah, that algorithm would be a loop within a loop, and with big O notation that would be order n squared, which, I don't know, it might work, but on basic it might be too slow. So I was thinking about it, and probably if we had like a modern programming language like Python, maybe I would use a set instead of an array to store the numbers. So that is just a collection of values, and it gives you a really quick way to check whether there's whether a particular value is in the set, because it uses like a hash table to check whether there's a value in there. So VC Basic doesn't have a set or a hash table, so if I wanted to do that, I have to implement it myself. But I was thinking about it a bit more, and the thing is, so all of the numbers, they're all positive, just looking through the list, and they're all obviously going to be less than 2020, because, well, we can just immediately discard any numbers if there were any that were greater than 2020, because obviously you can't add a positive number to 2020, to any number greater than 2020 to get 2020. So what we could do is, instead of using, we could just have a big chunk of memory to say whether any particular number is in the list, and that way we would only need one bit per possible number to say whether it's in the list. So if there is a maximum of 2020 values, isn't there, because of 2020 values, because yeah, obviously there's only 2020 possible unique integers up to 2020. So if we store one bit for each of those numbers, then we only need 252 bytes to store to have like a set to say whether each number is in the list or not. Okay, so what I'm going to try and do is just build up an array of 252 or 253 bytes with a bit to set whether each number is in the list. And then we can just iterate over the array, and we know what number would correspond to the number we're looking at to get to 2020. So it's obviously just 2020 minus the number we're looking at, and if that number is also in the list, then we found the answer. Okay, so I have to start by building up that list. I'm going to try and use the same trick that I did last time to generate a basic program that contains data statements that has the list of numbers. Okay, so I can remember what I did. So we're going to have an array of, well, let's not have an array, let's just, so there's another trick we can do. values. So that looks like it's creating an array of 256 integers, but if you don't put the brackets around basic, around the dim statement, it actually just reserves that number of bytes and then sets the variable to a pointer to those bytes. So because we only want 1 byte per entry in the table, it's more efficient to do that. So now we've got values will be a pointer to 256 bytes. So the first thing we want to do is clear that array. Let's just do that. So BBC Basic, so if you're familiar with other basics, to set a value from an address, you can just do poke. In BBC Basic, it has a sort of slightly neater way to do it, where you can just have an address and put a question mark to say it's a byte address, and then have an offset, and then just set the value. So we want them all to be 0 to clear the array. Okay. So now we're going to input all the values. So we'll just have a repeat loop. Okay, and then we'll just, if the value isn't -1, so we'll do the trick again where we'll stop inputting values when we get to -1, then we'll set a bit in that array. So we'll need to divide the number by 8 to get the byte number. So copy that. So we need to set the bits. So normally in a real programming language there would be a shift operator that you could shift by a certain number of bits to get the bit value. Don't think Basic has that. Let's just write bit for now. And figure out how to get that value in a minute. And then we'll stop the loop when we input -1. So let's try and figure out if there's a power of 2 operator. Is there something? About going to find the ASCII value of the gap. Wow, okay. So so we just need to set, so we'll go back to line 65, just need to set bit to the, copy that value, because I don't know how to type it, to the bit number, which will be value mod bit, so the modular remainder divided by 6. Okay, sorry about it. Okay, so then we just need to continue and do the trick to write it out to a file. Open out temp, so write each value out. So this is just typing the same thing I typed last time. Line number, and then the value, plus, and then the value from this byte array, okay. Print line to the file, 1 byte at a time. Input, paper input, but ASCII value of a character on that line. From the line, okay. And then we put the line down there. File. Okay, so this is like a program. Okay, this is it. Okay, now I'm going to paste in all the values from my input. Not quite what. What was the problem? 970. I made it so this is an array instead of, I forgot the byte thing. Okay. And we want question mark to say that it's accessing it as an offset from the address instead of as an array. And again here. Right, let's do it. Let's do this time. Okay. Oh, stop there. Let's include the value. You just stop when you hit -1, not any other number than that. Okay, let's drag it. Okay, with the actual value. Done. Let's see if I Okay, stop with the -1 and try to okay, should be just okay. Type of Oh, I forgot to convert the last value to string. Okay, let's begin. Let's do the beginning. Into the button. Stop the list. Okay, so it's writing it out to the tape. This is the button. Oh yeah. Okay, do it one more time. I forgot the hash. Oops. Okay, I've got a comment. Maybe you can't hear me, so I'll try and talk a bit louder. Or maybe I'll just turn up the volume of the microphone. Oh, I just talk louder. Okay. Okay, let's do this again. Pasting the values in, make it go faster. Add the last value, and then save it. Okay, so save this cassette somewhere. And I'll save the program as well. Okay. Okay, so I'll reset the emulator and to see if that worked to get the data. Okay, so we'll just do this trick to execute the ASCII text that we had as if we were typing it in. Okay, seems to be doing something. Okay. Okay, so we've got a bunch of lines. Now we can start our program. We'll rebuild the array from the data statements we just had. So let's add an extra data statement to mark the end, and then we'll have a while repeat loop. No, okay, we've already got the array at the start from 20. Make a repeat loop. So we'll read one value, and then we'll store it in this byte array. So we need the index. and we'll keep going until we get to -1. So we need to not. Actually, it doesn't really matter. We just let it add the value. Okay. So I needed to initialize my counter variable. Let's see what I forgot. Oops. Back to the 1000. Okay. Okay, so with that okay, so it builds up the values. I guess I can just check if that works. They're all 0. Let's just assume it worked. Okay, so now we can go from all the values from this is a good idea. Let's just do it anyway. Yeah, okay. From 1 to 2020. We'll probably okay, let's do it this way. That's quite a long loop, but yeah, let's do it anyway. Okay, so we'll check. Let's make a function to check if a number is within the array. Okay. Okay, so this is just we need to get the byte number is the number over 8, and the bit mask, the bit value will be we do this. Oh no. Type the. Sorry, I can't type the character on the emulator. Right, I've got no idea. Okay. Okay. So that's good. So the bit number is 2. Oh, I've lost my character again. To the power of the number what pick? Yeah. I guess you could need to go a bit faster. Okay. And then we just need to see if that number is set in the array. So yeah, that's that. And let's make it convert to a true or false value. So if it's not 0, yeah, I think I'll probably just work anyway, but let's do it like that. Okay. Look at the function we made. I guess you could test it with a number that I know is in the list. Oh. Okay, it won't work because we haven't created the array outside of the program. Okay, so where were we? Okay. So we can, now we've got this function, we can just go, if the number is in the list, and (2020) minus that number is in the list, then let's make a procedure to print the result. And then we're in the middle of a loop, so we'll stop the loop and end the program. And then we can define our procedure, which will happen once we found the number. So we need, the other number will just be 2020 minus that number. So then the final result that we want to have is the multiplication of those two numbers. So let's print both numbers. And then the result. And finish the box. Let's just run it, see what happens. It's doing something. Let's make it go faster. Okay, I didn't find anything. So do we have this? Now we have this array. Can we check whether this function actually works? So I know that this number should be in the list. No, it's not. Okay. So we can look at this number. So it should be in byte number 226. Which is 0. So if we started on line number 1000, so that would be on line 1260, right? 0. Let's see, are there any set there? So it should be bit 6. So that would make it 64. So there should be a, so it should be like this. For one. Oh no, I listed the wrong number. 226. Oh, so it should be 326. So, okay, so that's the line number that should contain the bit for that 1814. So that is the 201 have bit 64 set. Oops, no, that's not what I wanted to do. Yes, okay. So it looks like the program, the data is correct. but maybe the function to read in all the values is not. Oh, so I've done a very stupid thing. I forgot to increment the iterator variable. Okay, so let's try that again. Make it go back. Nah, still no. Okay. Well, let's check that this function is working again. So another number that should be in there. Yeah, okay. So it looks like the function is working, or let's just check for a value that isn't in there, probably. Right, some more numbers. Okay, so that function seems to work, so that makes me think that and let's just check what happens if I call this function when it finds the actual number. Okay, so it makes me think that the loop isn't working. So what is that again? Okay, so we go from 1 to 2020. If it has the number and it has 2020 minus the number and proc bound. I've done I'm looking at the wrong variable. Okay, so that was stupid. I want to look at the iterator. Okay, one more time. Oh, I've done the same stupid thing. I missed using number again. So print the actual number we found. So does that mean it's found two numbers? That's a bit suspicious. Oh no, wait, because yeah, so there's two numbers. Okay, that makes sense. Okay. So the answer that I need to type in is this one, 437931. Let's check if it works. Okay, it's correct. Oh, thank goodness. Okay. So I'll do part 2 later. So thanks for watching. Goodbye.